All right, so we're going to continue graphing these rational functions, and we'll go through all of these steps. And remember, any step that's asked for should appear on our graph. So we've got the function f of x equals x squared minus 1 over x squared minus 2x minus 8. First, it says find the vertical asymptote, or asymptotes. So this is where we take our denominator, x squared minus 2x minus 8, and set it equal to 0. I don't care about the numerator for this, just the denominator. And I'll factor to solve this, getting x minus 4 times x plus 2 equals 0. Set each factor equal to 0. And I get my two vertical asymptotes, x equals 4. And my second vertical asymptote is x equals negative 2. And by the way, before I go ahead and sketch this, remember that issue of holes? I just want to double check and make sure that one of these isn't a hole. And if a couple of ways I could do that. One, if I take a look at my graph, y equals x squared minus 1 parentheses over parentheses, and then x squared minus 2x minus, oops, not minus, sorry, clear, I cleared the whole thing, sorry. X squared minus 1 parentheses over x squared minus 2x and then minus 8 close parentheses. There we go. So if I look at the graph, it does look like at x equals 4 and at x equals negative 2, I do have vertical asymptotes. So graphically, it looks like these are vertical asymptotes. The way that I can confirm it algebraically to make sure that these are asymptotes and that this isn't a case where there's a hole that exists in the function where it would kind of appear to the naked eye like it's continuous, but there will be that little hiccup. So I just want to make sure that I factor the numerator and denominator, x plus 1 times x minus 1 over x minus 4 times x plus 2. And you can see that there are no factors that cancel. I can't cancel out any of those factors in the denominator. So that means that there are no holes in my graph, only vertical asymptotes coming from the denominator. So just want to double check that. I didn't do that in number 6 just because I could see pretty easily that they wouldn't cancel, but 3 times x plus 2 over x plus 1. Again, no factors would cancel. That x plus 1 wouldn't cancel out, so I knew that that wasn't a hole. Okay, so we've got our two vertical asymptotes. Let's go ahead and find our horizontal asymptote. So remember, this is where we're comparing the degree of the numerator, which is 2, to the degree of the denominator, which is also 2. Because the degrees match, I'm going to use the ratio of those leading coefficients. So y equals 1 over 1, which gives me y equals 1. So that's going to be my horizontal asymptote. So let me go ahead and sketch these on my graph as dashed lines. So x equals 4, vertical. So there's x equals 4, x equals negative 2, vertical asymptote, and then my horizontal asymptote y equals 1. There we go. So I've got my vertical and horizontal asymptotes sketched on my graph. Moving forward, find the y-intercept. So on my graph, it's not really obvious what this is. So this is the case where you would want to plug in f of 0 and see what you get. So f of 0 equals 0 squared minus 1 over 0 squared minus 2 times 0 minus 8. So this gives me negative 1 in the numerator and then negative 8 in the denominator. So we have the ordered pair 0 and then 1/8. Right, so that's our y-intercept. Let me just double check that with my trace function. Plug in 0. So there's 0.125, which is equal to 1/8. All right, and then finding the x-intercept. Also, again, it's not obvious to me what these are on my graph. So let me go ahead and set this equal to 0, my function equal to 0. So if I set f of x equal to 0, that's going to be x squared minus 1 over x squared minus 2x minus 8 equal to 0. And remember, because we have this rational function, if I have a 0 in the numerator divided by some non-zero number, 0 divided by a number gives me 0. So really I'm just focusing on solving that equation. So I'm really just setting the numerator equal to 0. And then I can factor x plus 1 times x minus 1 equals 0. Set each factor equal to 0. X equals negative 1 or x equals positive 1. So these would be my two x-intercepts, negative 1, 0 and positive 1, 0. Let me just verify that with my trace function. So 1 for x gives me 0 for y. Negative 1 for x also gives me 0 for y. Okay, so let me go ahead and plot those intercepts on my graph. So my y-intercept is 0, 1/8, so just a hair north of the origin there. And then I have 1, 0 and negative 1, 0 for my x-intercepts. Okay, great. And before I start pulling out additional points, let me determine the symmetry. So remember to do this. This is where I calculate f of negative x. So for this function, let me just clean it up a little bit because I sketched on it. So f of negative x equals negative x in parentheses squared minus 1 over negative x in parentheses squared minus 2 times negative x and then minus 8. Negative x in parentheses squared is positive x squared minus 1. And then negative x in parentheses squared is positive x squared. Negative 2 times negative x gives me positive 2x. And then I have my minus 8. So that's f of negative x. Now I can see right away that this is not equal to f of x. My numerator matches x squared minus 1, x squared minus 1. But in my denominator, I have x squared minus 2x versus x squared plus 2x. So it's not an exact match, right? So I know that f of negative x is not equal to my original f of x function. So that means it's not an even function. There's no y-axis symmetry. And checking for odd functions, in this case, I would have all different signs. So if I had negative f of x, I would either have negative x squared plus 1, and then my denominator would be unchanged, but that's not what I see down there. Or alternatively, if I had negative f of x, I could also keep the numerator the same, and then I would have negative x squared plus 2x and plus 8. But again, that's not what I see down here. I have x squared plus 2x minus 8, so I don't have a match in the denominator. So I also know that f of negative x does not equal negative f of x either. So that means there's no symmetry. No origin symmetry, no y-axis symmetry. All right, so now it says plot at least one point between and beyond each x-intercept and vertical asymptote. And here, it's not an exact science, but I just kind of want to fill in the graph. So it looks like my graph occurs here between my two vertical asymptotes, and then occurs up here, but not down here, occurs up here in this corner, but not down here. So I'm going to look for a couple of points just to guide me to the left of x equals negative 2, points to guide me to the right of x equals 4, and then maybe just a couple of points in the extremes between those two vertical asymptotes. So not an exact science, but I'm just going to pick a few ordered pairs just to give myself the shape of the graph. And if the points that I pick aren't good, then I'll pick new ones. So here's x, y. All right, so maybe, let's see, maybe I'll do like negative 6. And then I'll do maybe negative 2.5 to get pretty close to that asymptote. In between my vertical asymptotes, maybe I'll do a negative 1.5 to the left of that negative 1 x-intercept, and then about a 2 to the right of my x-intercept of 1. And then to the right of that vertical asymptote, maybe I'll do, let's try x equals 5, and then x equals, I don't know, 8. Let's see how those work. And I'll use the trace function here. So trace negative 6 gives me 0.875. Negative 2.5 gives me about 1.6. So I'm just going to round that to 1.6. And these are just approximations just to give me guide points to graph these. So negative 6 and 0.875. Negative 6 and 0.875, so that's just a hair under 1. And then negative 2.5 and 1.6. So negative 2.5. And then 1.6 is right here. Just about. And see that my graph actually will cross under that horizontal asymptote, and that's okay to cross horizontal asymptotes. I just can't cross vertical asymptotes. I'm going to sketch up here like this. All right, at negative 1.5. I've got negative, call it negative 0.45. So rounding about negative 0.5. And then 2, let's try that, negative 0.375. All right, so negative 1.5 halfway over there, and then negative 0.45. So just a hair under here. 2 and negative 0.375. It's right about there. A little less than halfway. And let me go ahead and squeeze in another one. Maybe I'll do like a 3 here. Let me just try that. Negative 1.6. Smushing that in. So 3 and negative 1.6. Maybe about there. All right, so I'm going to go ahead and sketch this. Oops, sorry, that is really wiggly. Sorry, guys. It's hard to draw with this little iPad pen. Pretend like that's a little less squiggly. All right, and then for 5 and 8, again, just picking numbers, so we'll see if these give us good points. Gives me about 3.4, so 5 and 3.4. So that's about there. And then plug in 8 for x, and that gives me 1.575. So 8, and then a little more than 1.5. So that looks pretty good. All right, so again, skating along those vertical asymptotes, cannot cross those ever. All right, so let's take a look at number 8. Determine steps 1 through 4 for the given function, f of x equals x over x squared minus 9. All right, so first we want to find our vertical asymptote. I'm going to take my denominator, x squared minus 9, set it equal to 0. Factor to get x plus 3 times x minus 3 equals 0. Set each factor equal to 0. This gives me x equals negative 3. X equals negative 3 from the first factor, and then x equals positive 3 from the second factor. So those are my two vertical asymptotes. I'll represent those with dashed lines. I can see from my function that I'm not going to have any factors canceled because I just have a plain old x in the numerator. So these will both produce vertical asymptotes, but I can go ahead and double check that by creating my graph also, x over x squared minus 9, close parentheses. Yep, so I can see the vertical asymptotes occurring at x equals negative 3 and x equals positive 3. For the horizontal asymptote, I'm comparing the degrees of the numerator, which would be 1, to the degree of the denominator, which would be 2. So this is what's called a bottom-heavy function, or what I call a bottom-heavy function. So this is going to produce our asymptote y equals 0. And I can see that in the extremes of the functions that my function is kind of leveling out at a function value of 0, y equals 0. So let me go ahead and sketch those. X equals negative 3. And then x equals positive 3. And then my horizontal asymptote y equals 0. Okay, there we go. All right, so find the y-intercept. F of 0 would be 0 over 0 squared minus 9, which is 0 over negative 9, also known as 0. So y-intercept at 0, 0. And I can confirm this on my function, on my calculator, x equals 0, y equals 0. Find the x-intercepts. This is where we set our function equal to 0. So x over x squared minus 9 equals 0. Because I have a rational function, I'm basically just setting my numerator equal to 0. So if y equals 0, then that means x equals 0 as well. So the x-intercept and y-intercept are one and the same, just occurring at the origin. Okay, so 0, 0. So that's all we've got so far. Obviously, we'll want to fill in a few more points. And again, notice that 0, 0 lies right on that y equals 0 horizontal asymptote. That's fine. We just can't cross the vertical asymptotes. Now let's take a look at the symmetry. So remember our function is f of x equals x over x squared minus 9. So for f of negative x, I'll do it up here. F of negative x equals negative x over negative x squared, in parentheses minus 9, which gives me negative x over positive x squared minus 9. So that's f of negative x. All right, so I can see that that doesn't equal f of x, right? So f of negative x doesn't equal plain old f of x, because in my original function I have x, and in my f of negative x I have negative x up in the numerator, so it's not an exact match. But let's go ahead and see what we can find for negative f of x. So if I were to write out negative f of x, choose gray. If I were to write out negative f of x, I could either write that as, instead of x up top, negative x, and then the denominator would remain unchanged, x squared minus 9. Or equivalently, this could equal positive x up top, unchanged, over negative x squared, and then plus 9. So either of these are correct ways to write negative f of x. So let's see if we have any matches here. All right, so f of negative x equals negative x up in the numerator, and I see that I have a negative x in the numerator here, over x squared minus 9 in the denominator, and there's an x squared minus 9 in the denominator. So that means we actually do have a match between f of negative x and negative f of x. All right, so we can say that f of negative x equals negative f of x. Okay, so that means that we have an odd function with origin symmetry. Okay, so we have an odd function with origin symmetry. This is where if we have a point xy, that means we have a matching point negative x, negative y. So for every xy, we have a match negative x, negative y. Okay, cool. So we're getting there. Let's go ahead and create our x and y table. And looking at my graphing calculator for assistance, let's see, maybe we'll get like x equals negative 8, let's say, and then x equals negative 3.5, just to the left of my asymptote. Inside my asymptotes, maybe I'll get x equals, I don't know, negative 2 and positive 2. And then out to the right, maybe I'll get a positive 3.5 and a positive 8. So let's go ahead and try that. All right, using our trace function, negative 8 gives me a y value of negative 0.145. I'll just round it there. And by the way, that means that I know positive 8 is going to give me positive 0.145. I can double check that, and I'm right. And that's from the origin symmetry, right? Typing in negative 3.5 using my trace function gives me negative 1.08 if I want to round it there. And that means, by the way, positive 3.5 will give me about positive 1.08. I can just test that with trace. I'm correct. And then if I plug in negative 2, that gives me y equals 0.4. That means positive 2 should give me negative 0.4. And it does. All right, so let's go ahead and sketch these, see if we like what we've got. So negative 8 and then negative 0.145, so just right under that horizontal asymptote. Negative 3.5 is at negative 1.08, so just a hair under 1. And then we'll kind of skate along these asymptotes here, not crossing that vertical asymptote. In between, negative 2 gives me 0.4, so about halfway between 0 and 1. And then positive 2 gives me negative 0.4. And again, I'll skate along those vertical asymptotes, but not cross them. And then out to the right, 3.5 and 1.08. So just a hair above 1. And then 8 and 0.145, just a hair above 0, and skate along these asymptotes. Okay, so there's a sketch of my graph.